A very good evening, students. In previous class, we discussed about statistics as well as arithmetic progression. Now, this class will discuss about circles. Final exam point of view. What are the important concepts you have? Let me start this class. And now, let you learn about the definition of circle. As you know, earlier classes, circle is collection of all points plane, which are a constant distance from a fixed point. That fixed point itself is called as center of the circle, and fixed distance is called radius of circle. And we can define like this also: a path of point from a fixed point with a fixed distance. As we know, fixed point is called as center. The distance from fixed point to the point on circle is our distance. Constant distance or fixed distance is called as radius of the circle. 2 times of radius of circle is diameter, and chord of the circle means a line segment joining any 2 points on a circle is called chord of the circle. So we can define diameter, as we discussed, is the longest chord of the circle, which is 2 times of the radius. And tangent, when a line meets a circle at only one point or two coincidence, I mean, a line is known as a point, the tangent. The tangent of circle is perpendicular to the radius through the point of contact. Once again, I'm saying, repeating, children, students, the line segment or a line which touches only one point on the circle is called as tangent. Tangent is always perpendicular to the radius, or radius is always perpendicular to the tangent. This is one of the important theorem of the circles. Let me go with next slide. Now, the properties of tangents to a circle. First property, the tangent at any point of circle is perpendicular to the radius through the point of contact. As we know, tangent means a line or line segment which touches at one point on circle, and the point at which point is circle intersecting on circle is called as point of contact. If you draw any line segment, from center to the point of contact, it is always perpendicular. As we know, perpendicular means it is exactly 90 degrees. So we have to prove here perpendicular. OP is perpendicular to the tangent XY at point of Q, at point of contact P. Let me take another point Q on XY. If you observe, students, as we know, inequality of triangle, if you take another point OQ, not only OQ, if you draw many line segments other than OP, if you draw many line segments from O to the lines tangent XY, then the shortest distance itself is OP. So as we know, from any external point, any external point to a line, which is shortest distance means which is exactly 90 degrees. From this, we can conclude that OP is the shortest distance drawn from the external point O to the tangent XY. Here O is center of circle, OP is radius. So OP is always perpendicular to the tangent at point of contact. This is very, very important theorem, students. Based on this only, we have many applications and circles. And sometimes, many times, it is given in final exam point of view also for as a 2-mark question. Prove that the tangent at any point of circle perpendicular to the radius through a point of contact. First write given, RTP, nothing but to prove construction, and this is the way proof. By using inequality of triangles process, we will prove OP is the shortest distance. As we know, from any external point to the line, if it is shortest distance, it is always perpendicular to the given line. So OP is perpendicular to the tangent XY at point of contact P. And next, we'll go with next slide, students. Next slide about property 2. Prove that the lengths of tangents drawn from an external point to a circle are equal. Once again, students, we can draw maximum 2 tangents from an external point to a given circle. Maximum number of tangents we can draw through a given tangent, given circle. Maximum number of tangents we can draw from an external point to a given tangent are maximum 2 only. Now we are proving these two are equal in length. Let us take according to the figure. P is an external point, O is the center of circle. For this center of the circle, for the given circle, PT and PS are the two tangents drawn from an external point P. Now we are about to prove PT equals to PS. That is means length of tangents are equal, which are drawn from the point, external point P. And then after to prove this one, we have a construction that is join, that is join OP. After joining OP, students, after joining OP, we get OOTP, OST. OTP, OSP are two right triangles. If you observe OT equals to OS, which is radii, angle OTP, actually we'll start with RHS means first right angle. Angle OTP equals to angle OSP, which is right angle, and here OP equal to OP, which is hypotenuse, hypotenuse common side, and OT equal to OS, which is radii side. So from this we can conclude by RHS. By RHS congruence rule, triangle OTP congruent to triangle OSP. Already you have learned in class 9, when two triangles are congruent to each other by CPCT, corresponding parts of congruent triangles. By corresponding parts of congruent triangles, PT equal to PS. Hence it is proved. Hence it is proved. So hence proved that the length of tangents are equal. So students, it is proved that the length of tangents drawn from an external point to a circle are equal in length. So now once again I am repeating, student, construction join OP and join OT OS, and we have to prove PT is equal to PS, and it is given center of circle PS, and PT and PS are the tangent drawn from external point P to the circle with the center O. Now we will prove OTP OSP are congruent to each other by right angle, hypotenuse, side. By RHS congruence rule, both are congruent. By CPCT, PT equal PS, which is nothing but length of tangent drawn from an external points are equal, hence proved. Let us go with, this is also very important theorem, students. Many times repeatedly they have given for 3 marks question or 2 marks question in final exam, as well as applications are also very important. Throughout circles we have only two theorems mainly. This theorem as well as radius is always perpendicular to the tangent at any point of circle. These two, based on these two theorems only, many applications are there. Let us go with next uh, problem. Yes, student. Prove that parallelogram circumscribe a circle is a rhombus. Here it is given many times this problem. Previously we have discussed how to prove AD plus AD plus CD equal to AB plus CD equal to AD plus BC. Up to these steps are same, students. Tangents drawn from external points are equal in length. We'll write, and then we'll write these all add up. After that, till here it is same. Till this step it is same, students. But we know that in a parallelogram opposite sides are equal. Here we wrote AD and AB equal to CD, AD equal to BC. So instead of CD we can write AB since it is a parallelogram. Instead of AD we can write BC since it is a parallelogram. 2AB equal to 2BC. Here these two cancel. After 2 to cancel, we have AB equal to BC. From 1 and 2 we can conclude that AB, BC, CD, DA, all lengths are equal. A parallelogram in which all sides are equal is called rhombus. Hence it is proved. So this is the way to prove a parallelogram is a rhombus when it is a circumscribe a circle. But uh, uh, up to proving previous theorem, same process we do. Only the thing is, we will prove in this parallelogram adjacent sides are equal. In a parallelogram, if length of adjacent sides are equal, it is a rhombus. Hence, it is proved. The next slide already we discussed this. Now here also we will use same theorem. AP equals to AR because length of tangents equal. BP equals to BQ, length of tangents drawn from an external points are equal. CR equal to CQ, length of tangent drawn from an external equal. Add up these all. AP plus BP plus CQ equals to AR plus BQ plus CR. As we know, AP plus BQ is AB, AP plus BP is AB, and plus CQ equals to AC plus AR plus CR is AC plus BQ. Then after that, after joining these all the points to get the result, area of triangle ABC, we know previously that we can divide into three parts. Then from the 3 points, three parts we can write obvious formula. After substituting, we got half of AB plus BC plus AC. R is common R. Therefore, we can conclude that area of triangle ABC as half into AB plus BC plus AC, nothing but perimeter of ABC. Hence, it is proved. This is one of the important theorem in circles by using the concept of tangents drawn from external points are equal in length. And student, don't forget to write the conclude statement hence proved, because this is also important point. Some cases there is a chance of losing half mark if you don't write this small point. So let us go with next point, next slide, students. So next slide, it is given that if a tangent at a point P to a circle with center O cuts the line through O such that PQ length is 24 centimeter, OQ length is 25 centimeter, find its radius. Actually, it is unknown. If you observe, we know that OP is perpendicular to PQ from theorem 10.1. Actually, we should not say theorem 10.1. We should say that we know that radius is always perpendicular to the tangent at point of contact. So here a OPQ triangle by Pythagoras theorem, hypotenuse is OQ square equals to OP square plus PQ square. Substitute the values whatever we know. 25 square is 625 equals to OP square plus 24 square is 576. If you transpose another side of equality, it will become 625 minus 576, as we know 49. OP square equal to 49, we can write 7 square. When base are equal, we can cancel powers. So OP equal 7 centimeter. Hence, radius of the circle is 7 centimeter. Here we use theorem 10.1. Already I said we will use theorems 10.7, 10.1 or 10.2 for proving these type of problems. The whole chapter is based on 10.1, 10.2 only. Let us go with the next slide, students. Now we'll discuss that. Here it is given. Here it is given from a point, any point, common chord to intersecting circles, the tangents to be drawn to the circle, prove that they are equal in length. According to given question, these two circles with O center, C center intersecting each other at Q and R, PT, PR, PS are the tangents drawn. PT is tangent to one of the circle, PS is tangent to another circle, and here PR is the here if any point common chord, here common chord is QR, common chord to intersecting tangents drawn from the circle, they are equal. How to prove? Here we have to prove PT and PS are equal. If you observe, PT is the tangent of tangent, PQR is the secant. Here PQR is the secant of the circle center O. So we have a theorem that PT square equals to PQ into PR, because here according to theorem we can write it when tangent is intersecting, PT square equals to PQ into PR. There is one theorem. So from that, similarly PS is a tangent, we can write from the same theorem PS square equal to PQ into PR. From this we can conclude that PT square equals to PS square, and square square cancel. So PT equal to PS, hence it is proved. So this theorem you need to remember when a tangent is intersecting and a secant is intersecting another a circle, a same circle, then we have a theorem that tangent square equals to P, P, PQ. I mean it, a tangent of the circle, PQ, the line segment into the secant, product of secant. So we can prove like this, students. So hence it is proved that those two tangents which are drawn to the different circle, though from this theorem, it is they are equal in length. We can prove it. Again, we go to with next slide, students. Then next slide we have that out of, out of two concentric circle. As we know, concentric circle means if two circle having same center are called as concentric circles. Then radius of outer circle is given 5 centimeters and chord is it is 5 OA is 5 centimeters and the chord length is given 8 centimeters. Then we need to find radius of inner circle or else smaller circle. As we know in class 9 you people have learned, if you draw any line segment or line from center of the circle, for suppose if you draw any line segment or line from center of circle to the chord of the circle, it is perpendicular bisector. You have learned in circle chapter of class 9. Once again I am repeating it. In circle chapter of class 9 you people have learned that if you draw any line segment or line through the point of contact to through a chord of the circle, is a perpendicular bisector. Means from that we can say that the length of AD is 4 as well as CD also 4 and here OAD is triangle OAD is a or AOD is a right triangle, because from class 9 you have learned if you draw any line segment from center of the circle to the chord of the circle, it is a perpendicular bisector. Here AC is the chord to smaller circle, OD is the radius are drawn from center of circle. Anyhow, of course it is radius, so it is perpendicular bisector. So AC is divided into two equal parts, that is 4 centimeter 4 centimeter, because it is given the length of length of chord of small circle is 8 centimeters. So AD equal to DC equal to 4 centimeters and also perpendicular. So OD bisect the chord. In triangle OAD by Pythagoras theorem, we can write hypotenuse always opposite to 90 degrees. So OA square equals to AD square plus DO square. Hypotenuse square equals to base square plus perpendicular square, or sum of the remaining two sides also we can. Now we need to find OD, which is nothing but radius of small circle. So if you make OD as subject, DO square equals to 5 square minus 4 square. When DO square is the subject or radius of the circle to find, we have 25 minus 69. We can write DO as DO equals to, if you square can change into root. So root 9. What is the value of root 9, students? 3. So radius of smaller circle or inner circle is 3 centimeters. Once again I am repeating, students, whatever you learn class 9, if you draw any line segment from the center of the circle to the chord of the circle, it is perpendicular bisector. Here OD is radius of small circle as well as AC is the chord of the small circle, inner circle. So it is perpendicular bisector. OA is the radius of outer circle or bigger circle, that is 5 centimeters. As we know OD perpendicular bisector, AD become 4 centimeters, CD also 4 centimeters. In triangle OAD, as it is right triangle, apply Pythagoras theorem, then we get the radius of inner circle as 3 centimeters. Let us go with next slide, students. In next slide is given if PA, PB are tangents drawn from an outside of point, external point P, such a way that PA equals to 10 centimeters and angle APB equals 60 degrees. Find the length of AB. Very simple, students. Here AB length we need to find. As we know, length of tangents drawn from an external points are equal in length. When these two lengths are equal, it is 10 as well as it is also 10. It is also 10 because length of tangents are equal. When it is 60 degrees, and as we know, in a triangle if two sides are equal, opposite angles are also equal. Let us take x and x. So as we know, these two angles are equal, and apply angle sum property in triangle APB. We have APB plus PAB plus PBA equal to 180 degrees. Angle sum property of triangle. But already APB given 60 degrees. But instead of PBA, we can write PAB, because when two sides are equal, these two angles also equal. So we wrote 2 angle PAB equal to plus 60 can change into minus 60. 180 minus 60, 120. So PAB equals to angle PAB equals to angle PAB nothing but angle PBA also. Angle PAB equals to 120 by 2, which is 60 degrees. So we have 60 degrees. All sides are equal. All angles are equal because it is an equilateral triangle. As we know, PAB, PB are equal, and as we already it is given 60 degrees. If all these three angles are equal, which type of triangle it is? Here it is 60 degrees we got. Already it is given APB given 60 degrees. As we know, this is also 60 degrees. So it is an equal triangle. As we know, it is an equal triangle. All sides are equal in length. So AB is 10 centimeters. So hence the length of AB is 10 centimeters, which is nothing but chord of the given circle. So by using these properties, we can prove that the length of chord AB is 10 centimeters because these two tangents equal, it will become, angles are also equal. So automatically we can prove each angle measures 60 degrees. When each angle measures degrees in a 60 degrees in a triangle, it is an equal triangle. According to properties of equal triangle, all three sides are equal. AB is one of the side of PAB triangle. As we know, PA, PB are length of tangents. They are equal to 10 centimeters. Automatically, according to the properties of equal triangle, length of chord of given circle AB is 10 centimeters. Now next we go to with next slide, students. So next slide, it is given that two tangents PA and PB are drawn to the circle center O such that APB is 120 degrees. Prove that OP equal to 2 times of AP. Same way, students, given RTP you can write. Here given is, before prove that whatever given that is given, after prove that what is given RTP, and take midpoint of M such that AM equals to AM and join OA also, and proof in a right triangle OAP. In right triangle OAP, we know that it is a right triangle. We can prove these two congruent triangle. So it by OP bisects angle APB. That is why it is 60 degrees. As we know, AOP also 90 minus 60, 30 degrees. So M is the midpoint of hypotenuse. So OMO, MA, MP are equal. So after that, from this, we can prove that those two lengths are equal. Now let us go with next slide. From an external point P, tangents PA, PB are drawn to the circle with center O. PAB, if PAB is 50 degrees, find the AOB. As we know, these two are tangents equal in length. So automatically, or else we do one thing. As we know, OA is perpendicular to AP, so it will become 40 degrees. So if it is 40, automatically it is also become 40 degrees. As we know, in a triangle, sum of sum of three angles is 180 degrees, as sum of these two is 80. So angle AOB is 180 minus 80, that is 100 degrees. And let we go with the next slide. And we can do as by using cyclic quadrilateral property also. We have two different methods. One is, we know OA is perpendicular to PA 90 degrees. So here already it is 50. As we know, two tangents are equal in length, it is 50. Whether it is 50-50, these two will become 40-40. In a triangle, if sum of three angles is 180, 40 plus 40, 80. So 180 minus 80, 100. That is one theorem, one method. Another method is by using angle sum property as well as cyclic quadrilateral property also we can do. These are all the two methods. So let me go with next slide. So it is given that the lengths of three concentric sides of quadrilateral circumscribing circle 4 centimeters, 5 centimeters, 7 centimeters respectively determine the unknown fourth side. ABBCCA given, students, very easy. We know that AB plus CD equal to AD plus BC in a quadrilateral circumscribed circle. Just now we discussed when we are proving a parallelogram as rhombus, we proved AB plus CD equal to AD plus BC. Here substitute the values whatever we know and solve it. We know that if a quadrilateral circumscribe a circle, then AB plus CD equals to AD plus BC. Substitute the values whatever we know and simplify. We get AB plus 5 equal to 4 plus 7, which is 11, plus 5 can change into minus 5, 11 minus 5 is 6, So automatically AB length is 6 centimeter. These are the different applications of circle, students. I will do one more video on circles because little more number of problems we need to discuss. So we will discuss some more application on circle. Let us go with next class uh, remaining applications of circles chapter. Please, I hope to show that you all are understood this problem. So please, only going through this video is not enough. You please go with practicing part also. This is my uh, contact number. You can contact me for further. You can contact me further doubts clarification. That is 739-639-4288. Once again, I am saying, students, 739-639-4288. So thank you, students. Please go through my video class as well, and I will give even case study based questions also. Thank you, students. If you have any queries, please call to this, please WhatsApp to this number. Thank you, students.